Okay. All right, so what we were trying to find was the highest common factor of these things, and that was to look at the numbers first again. This doesn't change to our expanding section that we did the other day. So our numbers first, and then we look for any common coefficients or letters. All right, so we can do any of that. The first thing we're looking at are the numbers. Being 3 and 6, we're trying to find the common factors there. The factor of 3 is 3 times 1, and the common factor is 3 times 2. So that which is common is the number 3. So the only common factor we have here is 3. If I was to look at this one, what's the common factor of 16z and 20z? 16 could be 4 times 4. The reason I chose 4 is because they're multiples of 20. 5s aren't multiples of 16. So 4 times 5 will be 20. So the common factor is 4. And they both have a z. So the highest common factor here is 4z. It's common to both of them. All right. If I look at the highest common factor here, we're starting to get up to a number of them. Just pause that. Do you realise what you did, Gareth? In this next one, we have the numbers 13 and 15. There is no common factor there. Because 3s might go into 15 and 5s might go into 15, but they don't go into 13. So there's no common factor there. A and B are the common factors there. But there is no number. You might want to put in a 1 if you wanted to. Who's in question 2 now? Is anyone in question 2? Yep. If we looked at this one, for example, Jeremy, c cubed looks like this. And 5c looks like that. Okay, so the common factor there is just one of the c's. Alright, and we'll go up to this one. What's the common factor of these? I'd use 2s, I wouldn't use 4s because I know 4s don't go into 18. Yep. So I'd use 2s into 8 is 2 times 4. And that is 2 times 9. So the common factor is this and this. I'd go through this process in my book as well because when they get harder it's easier to miss things. This is x times x times y, whereas this is x times y times y. The common factor there is that and that only, not that and not that. Okay. Alright, so a common factor is 2x and y. 2xy for that one. Okay. Yep. Any?
3 go into 26 and 39.
3s can go into 39 but can't go into 26. No. What question are you working on there?
J.
J in question 1. 2. This one here?
Yeah,
in 1. 12b? Oh, 12a. Yep. This one here?
Yeah.
Yeah, sorry.
Nothing A, it's just GH.
It's just GH, that's right. I'd probably put a 1 GH there.
You said leave it out.
Yeah.
Last time with
Yeah, GH is alright then. Yep. Oh, 13s, yeah, 13 could go into it. Yeah, absolutely. 13s could go into it, Jake. 13 times 3 is 39. 13 times 2 is 26. Yep. This one.
Oh,
Yep, there's some paper here. D. Yep. So this one here, 8D and 2D squared. The one up. Yep, no worries. This one.
the 2D F and then F squared. Yeah.
That one. Sorry, mate. Yep. Okay, so just expand what we've got first. And here we've got what? F times F. It's only F. That's right. Yep. This one here, Jack, what have we got here?
C times C.
Excellent.
And 5 times C. So it'd be C or?
Just C, that's right. So what we do by expanding them is we can quickly identify what are the common things. But if we just look at them, often we can get it right, but when they start getting like this, where you got some squares all in different areas, it's fairly difficult to identify which is which. Alright, so I would strongly encourage you to expand everything out first until you get it in your head. Sean?
Can you do y plus yz?
Yeah, where's that, mate?
12b I.
12B I.
Yep.
That one? Yep. So just what I said probably to Jack is useful feedback. Fully factorise y plus yz. Okay. So expand them first. All you've got here is y, but here you've got y times z.
Yep.
Okay. You got a plus in the middle. So your common factor is that. And that goes out the front. All right. And then you need to think to yourself, what would I have to times y by to get y? Because that's going to have to go up the front of my, because remember everything outside is multiplied by that which is inside. Because we're going to have that set up, aren't we? Yeah. What would I have to multiply this by in order to get the answer y? I'd have to multiply it by 1. If I had 1 in there, y times 1 is 1y. Yep. And what would I have to multiply y by to get yz? Z? Yeah, because I'd have to multiply it by, because when I did everything outside by that which is inside, I'd end up with yz. And that's what my question ends up with. So that's the thought process that you're going through. You're saying, once I've found my common, once I've found what's common to both of these, which is y and y, that's got to go out the front. But then I'm saying in my head, well, I've got to multiply everything by that which is outside by that which is inside. What do I have to multiply this by to get this answer? Because that's the answer I have to get. I put a 1 there. What do I have to multiply that by to get yz? Well, I have to multiply it by z to get yz. Because that says y times z. And the times being in there. Okay. Okay, so they're just saying and, so it means they're just completely separate things, and they're just asking you to find the common factor, the highest, I guess, common factor. So on one side you've got 3 times b plus 6, and on the other side you've got all of that. Now the only common thing you've got is the b plus 6. That's not common, and that's not common. Okay, so your answer to that one would just be b plus 6 is the highest common factor. Alright, makes sense? Yeah, okay. So then with this one, notice that it's really important to do this, and I'll show you why. With this one, you've got y squared out the front, so you've got y times y times y take 3. I've expanded this out. Really important process. Don't ever not do it. Here, I've got y times y take 3. And so I try to identify, well, what's common? Y take 3 is pretty obvious. What's less obvious if I don't expand them is that I've got a y out the front. Okay? So the answer to that one, in terms of the highest common factor, would be y take 3. Alright? So the really important process is to expand first. Alright? Yeah, so we're in H. Okay, have you tried expanding them?
Yeah.
Okay, so what did you get for an expansion of this?
Like, I didn't know how to expand that. Like,
Right.
that one.
You're writing everything you've got there. You're writing everything. And then in this one, you're likewise writing everything you've got there, but you're trying to make it as a multiple of this, if you can. 5 times what would give you that number? Times A. Yeah? If we weren't to worry about what's there, if we were just to look at this, if I said simplify that, you'd say, oh, it's 25A. Cool. If you were to simplify that, you'd say, oh, 5A to the power of 3. That's what we want. You know, we're expanding it, we're drawing it apart first. We're writing everything that's there. The reason why we write everything that's there is because we're trying to identify the fact that we've got an A and an A, and a 5 and a 5. We can only use one of them. Okay, we can't use both of them. We can only use one. If there were 2 here, we'd say that, well, we wouldn't even do that. But it would be 5A, that's right. 5A is a common factor there. Alright, they're the only 2 things that are common to each little expression.
For the 5 times 5, that has to be able to go into the first one as well.
Yeah, that's right. Yeah. And if you did, say you did, it was 25A, well, that would never work because you've only got a 5 here.
Yeah. So if it doesn't work, then it's just a 1.
Yeah, that's right. You're so used to rules, you want rules for everything, I think. Yeah. Keep thinking through it, alright? Importantly, guys, like all the others, what you would do is you'd pull it apart, okay? But before you pull it apart, it'd be good to acknowledge that they're all multiples of each other. They've got a common factor, and their common factor is 4, okay? So this one here, we will pull it apart by saying it's 4 times x times x. Then this one would be negative 4 times 2 times x. And this one would be plus 4 times 3. Can you see that I tried to make them all multiples of 4? Is that alright? And so with that being the case, we go through and we go, alright, the challenge is, I guess, Jess, is to not worry about that, just to look at this and this, but then this as well. That's the challenge, is first of all, so what's common to this, to this, to this? What's common to this and this is the 4 and x. But you've got to be careful there because there's no x here. So the only thing that's common here is the 4. Alright, once we take the 4 out, what's left in our brackets is x squared take 2 plus 3. Alright, and if we think back to distributive law 1, we can just check to see that's right really quickly.